So in this video, we're going to be deriving the equations for projectile motion for masses in gravitational fields, and we'll worry about the charged particles in electric fields at another time. Notice the study buddy in the background. So you can keep this completed version handy while we're working through. So we're going to start here with our initial velocity vector and resolve that into our horizontal and vertical components. So we have done this in class, and so I won't go over it again, but just to use the mnemonic, which is the memory aid of how to derive the equations for initial, horizontal and vertical components. So recall that I use a question and an answer. So y sine, and the response is cos x. So the equation for resolving the initial velocity into the vertical component is uy equals u sine theta. So the equation for the horizontal component is ux equals u cos theta. Now recall the two important characteristics about projectile motion in terms of the horizontal and vertical motion or components, that the horizontal velocity is constant, that is, there's zero acceleration, and the vertical motion involves vertical changing velocity or a constant acceleration, and that acceleration is due to gravity. So, and we know that is 9.8 meters per second squared downwards. So since horizontal velocity is constant and has zero acceleration, we can write that here. And we'll annotate, put the subscript here that we're referring to the horizontal acceleration. So here we've got vertical acceleration, and that's represented by g for acceleration due to gravity. So let's move over to the left here and have a look at these motion equations that are given in the syllabus. There's 3 of them. And recall, when we're analysing projectile motion, that the horizontal and vertical motions are independent of each other and therefore need to be analysed independently. So let's think of the vertical component as being parallel to the gravitational field, and that's our y-axis. And the horizontal is perpendicular to the field, and that's our x-axis. So let's start with deriving the equations for vertical components. So starting with equation 1. And let's think of it in terms of dropping a ball from rest, and recall what each of these variables are. So since ball's been dropped from rest, we've got an initial velocity, and will happen to be 0. Then we've got the final velocity of when the ball hits the ground. We've got the time it takes, and then acceleration due to gravity. So notice at the same time the variable that's missing is displacement. So let's rewrite this equation with our subscripts. So we've got the final vertical velocity equals the initial vertical velocity plus or the vertical acceleration and then time. So notice any of these ones with a subscript are actually vectors, and then we've got time as a scalar value. So, and recall over here We've said that acceleration in the vertical is equal to acceleration due to gravity. So our final equation. Moving along to equation 2, we've now got displacement. And in this case, we are missing the final velocity from this equation. So our vertical displacement is the change in position. So change in position in the y axis or y direction is delta y. And again, we've got our initial vertical velocity times time plus half times the acceleration in the vertical and then times t squared. So again, acceleration in the vertical is g. So we can write it like this as well. So notice in our third equation that time is the variable that's missing on this one. Let's now put in our subscripts. So we have the final vertical velocity squared equals the initial vertical velocity squared plus 2 times the vertical acceleration times our vertical displacement, which is the change in position in the vertical. And again, I'll just rewrite AY to equal G. So that's done, and we can move on to the horizontal motion. So instead of thinking about the complete projectile motion, we can just think of an object that's moving horizontally with a constant velocity or zero acceleration. So starting with equation 1, let's put in our subscripts. So we've got the horizontal final velocity equals the initial horizontal velocity plus the acceleration, horizontal acceleration, times time. Now, going back over here, the horizontal acceleration is 0 because the velocity is constant, so we can just eliminate that component and we get the final equation of Vx equals ux, or final velocity, final horizontal velocity equals initial horizontal velocity. For our second equation, our displacement or horizontal displacement is given by delta x, or change in horizontal position. And that equals our initial horizontal velocity times time plus half horizontal acceleration times time squared. And again, acceleration in horizontal is 0, so all of this cancels out. And then, whoops. So after that's cancelled out, we're left with delta x equals ux times t. Now we've got our final equation of motion, and we'll put in our subscripts on this one. So we've got the final horizontal velocity squared equals the initial horizontal velocity squared plus 2 times the horizontal acceleration times horizontal displacement. Again, AX is 0, all of this cancels out, so we are left with this. And that's it.